Assalamualaikum. I hope everyone is doing well and also in good condition because today I'm going to fulfill the needed of the final project for Manufacturing Technology 2 subject. I'm from Group 3 and I'm going to present to you guys about studies on solid-state welding and the application on aircraft industry. So without further ado, let's cut to the chase. But first of all, I would like you guys to know what we're going to for today. So first is introduction, literature review, application of diffusion welding, experimental setup, result and discussion, and for the last is the conclusion. So I hope you guys will enjoy this journey. Let's go. Okay, so first for the introduction. As we know, it is possible to perform solid-state welding without melting the material being connected. Welding occurs when materials are solid. This group of welding process includes cold welding, diffusion welding, explosion welding, friction stir welding, forge welding, and ultrasonic welding. The base material may be heated to a higher temperature during the joining process, even if heat is unnecessary. However, the temperature is lower than the melting point of the substance. Depending on the joint, it may be essential to apply pressure. There is also the factor of time, which can be as quick as microsecond or as long as a few seconds in some processes. So next is the literature review. In the literature review, I will explain each of the welding processes. So first is the cold welding. Cold welding is a solid-state welding process that uses few or no heat or fusion to fuse two or more metals together. Next, diffusion welding. Diffusion welding is a solid-state welding process used in metalworking that may combine comparable and dissimilar metals. For the third one is the explosion welding. Explosion welding is a solid-state welding technique in which one of the components is accelerated at a fast rate utilizing chemical explosion. Next is the friction stir welding. Friction stir welding is a solid-state joining technique that attaches two facing workpiece without melting the material. Forge welding is a solid-state welding procedure that involves heating two pieces of metal to a high temperature and then smashing them together. And for the last is the ultrasonic welding. Ultrasonic welding is an industrial procedure that uses high-frequency ultrasonic acoustic vibration to generate a solid-state weld between workpieces that are kept together under pressure. Okay, for the next part is application of diffusion welding. According to peers, the most frequent diffusion bonding technology in airframe manufacture is thin sheet with blow shaping. Thin sheet diffusion bonding and blow forming may be used to create lightweight sandwich structure, including pyramidal trusses, corrugate panels, and honeycomb panels. And next, according to Stephen, massive diffusion welding is revolutionary manufacturing method for generating heavy metal components that involve solid-state bonding of multi-sheets at lower inert gas pressure. Okay, next is the experimental setup. We've chosen the titanium TI6AL4V. The reason why we choose this titanium or this alloy is because it is strong, ductile, fracture tough, high temperature strength, quick characteristic, weldability, workability, and thermal processability, which is higher strength is easily obtained by heat treatment. This alloy may be found in a wide range of aircraft and engine parts. As you can see, The next picture is the stress strain behavior of titanium alloy. A two-phase alloy finely equizect alpha and converted beta phase. The ratio of the two phases is critical for flow stress in high temperature deformation. The diffusion welding process with titanium Ti6Al4V. Diffusion welding procedures of 3 to 40 sheets of titanium alloy were carried out under various circumstances. The tool was sealed and heated to a target temperature after stacking. Diffusion welding of Ti6Al4V was performed at a superplastic temperature, which is between 850 to 920 degrees Celsius. As you can see in this picture, there's various type of microstructure change that occurs at each stage. So first, the two surfaces come into contact, the oxide layer meet, and part of the oxide surface begin to break down. The first step of diffusion welding occurs. Next, the deformation is unavoidable due to the physical interaction of the surface under pressure. Voids will be segregated as shown in picture C. At picture D, void closure is nearly complete. At picture E and F illustrate that full solid-state bonding may be achieved when diffusion bonding is performed at 875 degrees Celsius. The process at its beginning, it is not yet complete actually. At picture B, we can see a full diffusion bond may be achieved at this temperature. Thin sheet diffusion bonding with superplastic blow forming. Diffusion bonding of the titanium alloy investigated in this work provides a diffusion bond microstructure. In manufacturing process of lightweight honeycomb panel, a lightweight honeycomb panel design is critical in an A-frame construction to accomplish complete component phase stabilization. Sandwich structure have exceptional rigidity, vibration damping, thermal acoustic, and insulation capabilities. A 3-sheet titanium sandwich panel can be produced at 1030 degrees Celsius for 30 minutes under 7.5 megapascal bonding condition. 3 mm in thickness, while the interior web measures 1.6 mm. Boron nitride powder as a stop of substance. Fit in the apparatus employing hydrostatic gas pressure, the pressure profile, and applying inert gas pressure. So this is a 4-node quadrilateral element. The skin surface come into contact, the blow forming process, and also the microstructure and thickness measurement were analyzed and compared to the analytical result. So for the result and discussion, titanium diffusion welding in an inert environment was employed to create near net sheet product. Grain boundary migration, a homogeneous microstructure, decreasing the weight of aeroplane component and cost-effective production. It's very costly, of course. The method is primarily beach-based. An exact value of deformation required to achieve high vacuum tightness for material is very impossible. And for the last, we've jumped into the conclusion. So in the conclusion, the diffusion welding has demonstrated its ability to replace prior method that used fastener. The majority of aircraft manufacturers have recognized the potential of this technology as a fresh idea for enhancing quality and efficiency. Diffusion welding is well known in the titanium industry, but further research is needed to ensure it applies to other metals also. However, by its character, weight reduction and better damage tolerance were the driving forces for identifying innovative material for the aerospace sector. So that's all from us. Thank you.